Okay, so we're going to look at Maclaurin expansion for standard series. This time round, we are going to use the MF26 the formulas in standard series to answer a slightly more advanced kind of expansion. Okay, so in my previous lesson, we talked about how to expand e2x, right? So this is actually kind of similar to, say, expanding sine 2x, or for that matter, let's say ln 1 plus x. Okay, so all these is actually a change in the coefficient of x, right? So in this case, you will replace the standard series with 2x. For the e2x, we talked about that in the previous lesson. And for sine 2x, you would replace x with 2x, okay, over here. And then when you have, I meant to write a negative, so like for example this guy, 1 minus x, okay? So in this case, you will replace your x with minus x. So all these will become minus x, all right? With a minus x whole thing square and minus x whole thing cube, so on and so forth. So because it's actually quite straightforward, all right? I didn't show that many examples in my previous lesson. Now, if you have any questions on those, feel free to ask me, okay? Otherwise, let's move on to the Maclaurin expansion for standard series for the more advanced type of expansion, okay? And what I refer to, okay, again, we'll learn by example, would be something like this. For example, you will be asked to expand 1 plus 2x minus x squared. There you go. All right, now you see that instead of having two terms, okay, we have three terms, right? Because there's actually two terms here. What we'll do over here is that we will simply treat this, okay, the one that I'm going to curly bracket, as x. So in other words, what we want to do is to pretend that the 2x minus x squared is actually x, okay? So when we were to expand using the standard series, okay, we have the formula here for easy reference. Now, what we'll do is we will replace all the x with this, okay? All right, it's very straightforward, okay? It's just a little bit more math, or really, I mean, simplification of the terms later on. Okay, so instead of x, I replace it with 2x minus x squared, okay? And then after that, we have an x squared over 2, so we will have a 2x minus x squared over 2. And then let's go one more, so that will be x cubed, right? So we replace that with 2x minus x squared, whole thing cubed, over 3 plus dot dot dot. Now, suppose the question asks us to list all the terms from the up to and including, okay, in ascending powers of x up to and including x cubed, all right? So what we'll do is that we will have to do until the x cubed, okay? We don't need the x to the power of 4 over 4, okay, which is the next term, right? That's not necessary due to the fact that it is beyond what the question asks for, right? It's x to the power 4 or higher powers, so it's not required. So we can stop here and then we'll just put a plus dot dot dot, okay? And then we move on, we expand all these terms, okay? So what I like to do is this, okay? Let's go ahead and expand this because we don't have any coefficient outside the brackets. Now for this one, what I'll do is I like to put it as half instead. It's a little bit more neat this way. And then we will do the expansion of 2x minus x squared, all right? Now for this term, you don't actually have to expand all the terms, okay? If you were to do that, you realize that you will have the terms that has a higher power than x cubed, right? Okay, I mean, it's quite easy to see here. You have the minus x squared times the minus x squared, which is the positive x to the power 4. We don't really need that, so we can actually omit that when we do the expansion. But since this is the first time we are doing this, let's just take it slow, all right? So if for some students, you can actually kind of like do this exercise mentally in your mind, and if you are able to do it and you notice that you don't make any careless mistake, that's fine. You don't have to actually write it out like what I'm doing, okay? But obviously I'm teaching right here, so it's best that I write down my the step by steps, okay? So Let's start, all right? I mean, for this one, it's actually pretty straightforward. We'll have the 2x times the 2x, okay? And then that gives us 4x squared. We want this term because it's up to and including x cubed, right? So 2 times 2 is 4, then x times x is x squared. And then after that, the next one would give me the term, which is up to x cubed. That's great. So that's minus 2x cubed, right? But not to forget, then we have the minus x squared times the 2x. So that will be minus 2x cubed, okay? And then the last term, as we have mentioned, that will be minus x squared times minus x squared. That gives me a x to the power 4. So we don't really want that. We could just, I mean, this is a lazy way to mean that there's some other terms, but we don't need that, okay? So that is exactly what you need to do. And either manually, okay, write it out, or mentally, okay? So just imagine the terms, and as you do it mentally, you calculate them and just write it down like this, okay? So I'm going to copy what we've calculated over here. So this would be 4x squared minus 2x cubed minus 2x cubed, okay? Now before I go on, just let me do a double check just in case, right? So minus 2x cubed minus 2x cubed, yeah, great. All right, then we'll put a plus dot dot dot. All right, you have to do that because then we are telling the whoever that's reading this that we know that there's more terms, okay, but it's going to be equal because that assumes that we actually included more terms, except that we don't really specify them, okay? Because one day, okay, we're going to talk more about this. This is actually presentation, right? So suppose if I erase this and I just put this, okay, and then I continue to do the expansion for this guy, okay? The thing is, without the plus dot 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 over here, okay, without it, all right, this is no longer going to be equal. It's no longer equal, all right? It is approximately equal to, okay, in some occasions. We'll talk more about this, about approximation later on. So let's not talk too much about those, okay? Now, what happens is that when you don't have the plus dot dot dot, okay, like I said, the plus dot 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 is kind of a way to tell people it's there, but I'm not really specifying it. When you don't put it down, okay, it's no longer equal because you don't have those terms. So they are not equal, right? Does that make sense? Okay, because when you really mean that it's equal to 4 plus 3 plus 2 plus 1, okay, I'm just using a different example. And this, if I were to omit the terms, okay, then the plus 1, for example, okay, is gone, right? Then in that case, it's no longer equal to what it would have been, okay? So if it's 4 plus 3 plus 2 plus 1, it's actually 10, right? But if we were to omit the plus 1, okay, just like we omit the plus dot dot dot, like I say, it's a lazy way of representing the unspecified terms, okay? We know that it is no longer equal to 10. Look at this guy now, it's actually 9, all right? It's close to 10, but it's not 10. So in that case, we have to use the approximate sign, okay? So I thought that's worth mentioning right now, okay? But we'll talk more about this. You'll see this come up again, okay? I'll explain it again in the context of those questions. But for now, okay, it is important to note as well, because your presentation, when you submit your solution to the examiners, okay, is for your exams, obviously, is important too. Okay, so coming back over here, all right, just to do a quick recall, we were here. Okay, so we expanded terms that we needed, which is up to x cubed, and we omitted the x to the power 4. And since I've put the plus dot dot back, now it's equal, okay? It's exactly equal. Okay, I don't have space, so I'm gonna write my expansion for this guy over at the bottom. So again, I'd like to put a 1/3 on the outside, and then this time we will expand this, which is 2x squared minus x squared to the power 3. Again, you could do this mentally, or you could look at this, okay, and write it out on a piece of paper or elsewhere to figure this out. Now, get good at this so that you know, you can actually do this pretty quickly mentally. Now, first off, remember this is to cube, okay? So we just need to list down the terms that is included up to x cubed, right? So the first one would make sense because when we expanded this, when we expand this fully, we'll have a 2x times 2x times 2x, and that gives me 8x cubed, all right? Okay, now what I want you to do is just do a mental exercise. You can pause this video if you want to and just look at what happens if you were to expand the rest of the terms. Okay, so let's say, for example, let's choose a different color. We have 2x times 2x. Now, since we have already multiplied with the 2x, so we're going to go on to the next term, right? So as you can see, we have x times x, or rather 2x times 2x times minus x squared. The power for the x would be 4 in this case, okay? I don't even have to figure out what is the coefficient of x to the power 4 for this product, but we know that we don't really need this term. Okay? All right? Now, I could move forward a little bit more. Let's say, for example, now that we have done this, we could, okay, let's just remove this one, all right? Just remember that we have done this. Okay, I don't want to remove it so that we don't have so much clutter. It's a little bit clearer. Let's go with this guy times this guy times this guy. Okay, all right. Then what happens again is that you have an x to the power 4. Okay, so you don't actually need that. Now, in fact, if you were to go through this exercise, going through and expand everything, you realize that there's only one term, okay, which is x. 8 to the power 8 times x cubed. Okay, this guy. There's only one term in this expansion that is with power 3, x cubed, right? The rest would have been higher powers. So in that case, we don't really need to go ahead and expand it, and that's why you could actually do this question pretty quickly, okay? Because of the fact that you don't have to expand all of them. You can just drop anything that is of x to the power 4 higher, okay? Now, we're gonna move forward, okay? So I need the space down here, so maybe I'm gonna move this slightly more to the left, okay? For those who want to dwell on this a little bit more, I keep this on the screen, but I'm gonna move forward with the lesson. Okay, it's time to expand this. So we have 2x minus x squared minus, okay, so half times 4, it will be 2x squared. We can combine this first, and that gives us minus 4x cubed. So minus 4x cubed times minus half, the sign is changed to plus, so 4 divided by 2, that gives us 2x cubed, all right? And then after that, we move on to the next one right here, which would be plus 8 over 3x cubed, okay? And then we can consolidate all the dot, okay, at the back over here, and that's fine, all right? Now, let's just simplify this on one last time so we can get our final answer. We have 2x, okay, minus x squared minus 2x squared, that gives us minus 3x squared. And then we have 2 plus 8 over 3, so that would be 14, okay, so this is actually 6 over 3, right? So 6 plus 8 is 14, so 14 over 3x cubed plus dot. And there you go, that's your answer. For the expansion of this ln, okay, 1 plus 2x minus x squared, okay? So that's the trick, okay? I call this advanced, all right? It's actually not so bad, all right? But from this lesson, I hope that you understand how to do an expansion when you have terms like this, okay? Just treat all the terms with the x's as if it's x. Use that as the replacement for the x in your MF26 Maclaurin expansion formulas.